Hello everybody, this is the tutorial video for the application of the tool HyMoLink. HyMoLink is a new tool which was developed in the project HyMoCARES to analyze morphodynamics in river channels and also to estimate the relevance of the morphodynamics for the provision of habitats to riverine species. Morphodynamics may be especially relevant for the rejuvenation of riverine species. Aggradation of bars may provide habitat to pioneer vegetation, to bar-breeding birds, and steep eroding banks may be suitable for bank nesting birds, and aggradation on the riverbed may increase the suitability for spawning for fish species. What you see here is the toolbox which was developed in HyMoCARES, and you see the tool HyMoLink here. So let's click on it. And HyMoLink is based on cross-section surveys, which should preferably be done annually or before and after larger flood events. Here is the Enter Data button, and we can upload here cross-section data. And this is how the file needs to be prepared. You need to prepare 3 columns. The first column should contain the cross-section name, and you have one cross-section following the other. Column B contains the lateral distance in the cross-section from left to the right side. And here we have 1 point every meter. And then in the third column, you insert the elevation above the sea level of the points. And you need to save this file as a CSV file to be compatible with HyMoLink. Then you can upload the data. So at first we need the earlier survey, and then we need the later survey. And what we also need is an elevation threshold between the coarse and the fine sediment. So this is relevant because we want to know if there is the possibility of fine-grained steep banks. So we need to have a fine sediment layer, which is usually the upper layer in the banks. And we load an according file. And you see this file contains the name of the cross-section and the elevation of this threshold in the cross-section between the coarser lower layer and the finer upper layer. Then we need water surface elevations of reference discharges. So we use these discharges to separate different zones. We have the aquatic zone, the semi-terrestrial zone, and the terrestrial zone. And we need to know the discharge which submerges the riverbed 50% of the time in the vegetation period, and the other discharge which submerges only 10% of the time in the vegetation period. If we know the discharges already, we can insert them directly, or we can use this tool of HyMoLink to calculate these characteristic discharges from a discharge time series. So we can upload a discharge time series. Here you see the format of the time, and we have the discharge. So also upload them as a CSV file. Here we use only 1 year of discharge to make the calculation quicker, but you should use a longer term series, probably 10 years, to have good representative discharges. Then we can enter the vegetation period. Here we have a vegetation period from the 1st of April to the 1st of October. And we can then calculate these reference discharges. And this takes a while. So you see we have now 2 discharges calculated, which are then used to model the water levels. For that you have 2 options. You can use your own model to calculate the water surface elevations for these discharges in both the earlier and the later geometries. Or you can use the calculations of HyMoLink. If you use your own water levels, you need to put your results into a file like this. This file has 5 columns. There's one column with the cross-section names. There's one column with the water surface elevations for the 50% discharge in the earlier survey. This is for the 10% discharge in the earlier survey, 50% discharge in the later survey, and 10% discharge in the later survey. But if you don't have your own results, you can also use the HyMoLink calculations, but this is only recommended if you have quite a uniform geometry, because these calculations are performed separately in each cross-section. So here you need for this purpose roughness, a channel slope, and here you can define a minimum vertical change for the declaration of morphodynamics. It depends on the accuracy of your survey, so I generally recommend to read the details in the deliverable DT231, where all this is explained more in detail. So now everything is filled and we can click on Run. Now HyMoLink calculates the water surface elevations in all cross-sections and in the earlier and later geometries, and it calculates the differences between the surveys. And it also assigns the differences to the different zones in the river channel. We can then see the cross-sections, and we can click through the different cross-sections. And what we see is that we have an aquatic zone, and this is the semi-terrestrial zone. So this is between the 50% discharge and the 10% discharge. And we have a terrestrial zone above. Here you see the threshold between the sediment layers. And you see colored here aggradation in the aquatic zone, degradation in the aquatic zone, and the same for the semi-terrestrial zone. You have here orange is degradation in the semi-terrestrial zone. Here you would have aggradation in the semi-terrestrial zone. What you see here is the minimum change of 10 centimeters until change is declared as a morphodynamic process. What we also get is a count of the bank erosion processes. So this will be automatically identified. We have here in the terrestrial zone at least 1 meter depth erosion in fine-grained material. So this increases the possibility of the existence of steep banks of fine-grained material. And on the left side you see the frequency diagram. So here you have the different elevation differences at different elevations above the water surface of the 50% discharge in the later survey. And the colors here show the frequency of occurrence of these combinations. And you see here you can switch on the areas which are relevant. So this is aggradation aquatic zone, aggradation semi-terrestrial zone, erosion aquatic zone is the red zone, orange is erosion in the semi-terrestrial zone, and we have the bank erosion in the fine-grained sediment layer of at least 1 meter depth. And the advantage of this image is that you can also show all together. So this is the result of all cross sections of this analysis. You can also save the image with a right click on the mouse. Also this one on the right. And when you scroll down, you can see here the results. So this is the horizontal distance in the cross sections with the specific morphodynamic process in the different zones. And you can now do the analysis for different time spans, and you can see whether morphodynamics will be increased or will be reduced. And in deliverable DT231, you can read about the relevance of these different morphodynamics for riverine species. So this all may be relevant, and you can see how it develops over time. And maybe it is also interesting for you to know what is the width change of the wetted width within the semi-terrestrial zone. So you have this value of this ratio for the earlier survey and for the later survey. You can also download this data once you have calculated it. Thanks for watching. You can find more information on the project HyMoCARES with this link. My name is Mario Klösch. If you have any suggestions for improvements or questions, you're very welcome to contact me. And you can also find more technical information on the tools with these two deliverables of HyMoCARES. Thank you very much. Goodbye.